Hello friends, today I am going to discuss second project like the heart disease analysis project. So I hope the previous project I did discuss and now today second project. So look here, first I am importing OS because I need to import a data from the Kaggle configurations. So previous video I have already discussed how to collect the data from Kaggles. So let here OS, now another this one the content and drive the Kaggles, and third is Kaggle datasets downloaded from this one. Another is the if file has given just like a zip file, so you can convert to into unzip file. So right here is, and it is converting into unzip file. Now we need to import the some libraries like import a panda as a PD, import matplotlib.pyplot as PLT, import cword as SNS, import numpy as a NP. So now I have been imported. Look here what type of the data has been imported. So this data has been imported, so we can see the data and it has number of the rows and the column. So there are 1025 rows and 14 columns. Now I want to see, do have any null sets in this set. So you can use the data because data as a variables, and dot is null and sum. So look here, we don't have any null sets in this data. Check the duplicate values. So data underscore dup, data dot duplicates dot any. So look here, yes, data dot dup. So yes, it has some duplicate value. So data, now I want to drop these duplicates value. So you can write here drop duplicates. So you may see the data. Now again check the data has been a duplicates value. So it has been data dot drop underscore duplicates. Now data underscore dup data dot duplicates at any data dot dup false. So all the duplicate value has been this. Now the next step will be the data processing. Most of the time we have to understand about data processing. So one variable I have been taking just cat underscore value like cost underscore value, and for using the for loop for column in a data dot columns, if data columns dot non-unique and parenthesis less than equal to 10, then cat underscore value dot append, I am using the append methods columns, and then else cost value append this methods. So look here, I am using. So now we need to understand cat underscore value has been like this: set cp fps rest tags exact slope ca file targets, and similarly the cost has been seen in this column like this. Now the encoding of categorical data. So data under data CP columns, and do have any, so it's it a unique value. Look here, 0, 1, 2, 3. So these are the unique values. Similarly, we want to remove from the 6 now the targets, and we can create this way. So look here, we want to the CP as this way, and now I want to see the data dot head. So it is converting into the like a categorical 1, 0 and this type of way, and the CP has been converted into like this 0, 0, 0, 0 and this type of CP1, CP2, CP. Now the feature scaling means from scalar pre-processing to import the standard scalars. So ST as a standard scalar, so the data cost value st.fit underscore transform data cost underscore value. So this is a standard scalar. So I think first we had to import the pre-process importing, and then we can use this one. Now it is a working here, and the data head has been given. These are the features like this. Next we can see the splitting the data into the training and test sets. So the x as a variable, data dot drop a target variable, axis 1 and x. So look here, data has been converted into as a target variable, and the y as a target. You can see here the what is the target. These are the values from the. Now another from the scalar dot model selections import train test split it. So now I am first importing this model, and then we can write here x underscore train, x underscore test, y underscore train, y underscore test, and train underscore test underscore split x comma y. Test size 20% I am taking as a train for x, y and test, and the randoms I have taken 42 because it cannot be the change again and again. So a y train, so I have taken, this is the way. So look here, if I use the twice, so your value will be I think same 163 to 91, so don't have to change. Similarly the y test, yeah, look here, these are the test data. Now I want to use the logistic regressions. So we need to show your data like this, age, sex, and these are the values has been given, and data targets is null. So look here, target means that classify the hot patient 0 and 1. We have been already classified these things. So now I use the logistic regressions. So linear models, look here, it has been imported, and it can intimate it as a log, and log fit means logistic regressions. And now I am going to predict this value. So the y underscore pred 1 log dot predict x test. So look here, the x test, and another the from sklearn dot matrices import the accuracy scores. So look here, what is your so we need to import sklearn matrices, import accuracy scores, and so now we can check here what is your accuracy score. So look here, 78% is the accuracy score like a logistic regressions. Similarly, I am using a second model, just SVM. So SVM, from sklearn import svm. So now the support vector means svm as a svc. Again I am using xtrain and ytrain, and next we can say the svm.
Sorry, there's
SVC.
nothing to repeat.
svc like this. So now what is the accuracy about this? So look like first I have been predicted, and then we can see the what is your accuracy rate. So this has been better than regressions model. Now I am using the k neighbors classifiers. So from sklearn dot neighbor import k neighbor classifiers. So first I am importing this one, and the second knn as a intimated as a variable, and now again I am using the same knn dot fit train, xtrain and ytrain, and now iy means I am going to predict like y underscore predict 3 and knn predictions xtest. And now what is the accuracy from this? Is the 73%, means it is not a better than. So similarly we can check here. So your which one is the better, and then we can easily check here accuracy rate. Now the score, and for the k in the range you can start from the 1 to 40, and knn k neighbor and knn fit and ky underscore predict, and a score appends. So like this one. So look here, you can use like this way. And what is the score? So you can see the all scores from here. So these are the scores. Similarly the k neighbors classifiers has been using directly, so it is a 80%. And if you want to use the non-linear ML algorithms, so same, if it is a non-linear, so you need to first again the data. Look here, we have already discussed these things, and duplicates, and what is the shape of this data. So the shape of the 302 rows and 14 drop and targets same way, and again the xtrain and test. So I am using the non-linear, so we need to the import from a sklearn tree, import decision tree classifiers. dt as a decision tree classifiers, and now the dt fit train, xtrain and ytest train, and now the predict number 4 predict xtest, and what is the accuracy? So look here, the non-linear, it is showing like a 70%. Again I am using the random forest is also for the non-linear, so we need to the import the sklearn dot assembles, import the random forest classifiers, and rf dot fit the xtrain and ytrain. Now the y predict 5 here, and it has means 83.6, it is a better than others. Now from sklearn is ensemble import the gradient boosting classifiers. So look here, and it is intimated as a gbc variables, and then you can again fit xtrain and ytrain, and now look here, predictions here. So it is a predicted value has been given 80.3. So final we can use the all these models like the final data PD pandas. I am using the pandas data frame and making the model like the LR, SVM, KNN, DT, RF, GBC and accuracy scores has been given. So look here, this one has been given here. So this is the way to look here which one is the better. So RF is a better. Now I want to plot of this. So I am using the import the CBORD as SNS, and now I am plotting this data sets like this way. So this is the way to predict your model, and so now this is the nice look, and you can easily predict which one is the better and you can use. Thank you for today.